Restoration techniques for BIOL3468, Biodiversity and Conservation. This is the second restoration ecology lecture. We'll be having the topic quiz on Thursday evening. I'll open it up online on My Learning for about 6 hours, so you can spend the half an hour that it will take to do the quiz anytime you want within that 6 hours. I'll send you an email to confirm all of that. So what do I want to talk about in this lecture? Really, we're taking a look at some of the techniques which have been developed in Australia to restore rainforests, and they come under some different titles: the framework species method, the maximum diversity method, the natural regeneration method, and finally the riparian regeneration method. And under the maximum diversity method, we're going to take a look at site preparation, planting and maintenance, which correspond quite well to disturbance initiation, propagule manipulation, and differential species performance, which we looked at how we manipulate succession in the last lecture. But these methods have been developed through a couple of decades of experience in far north Queensland in Australia, where they have patches of rainforest, in a similar sort of climate to Trinidad. So these techniques which I have developed can be applied here in Trinidad. They would be applicable in different situations, and hopefully I will be able to show you which conditions or which situations they will be applicable. Okay, the first method is the framework species method. It's also known as the building block method, where pioneer species or mid-successional stage species are used. Now, these species are selected species. They can utilize the massive amounts of resources of light and moisture, and if you fertilize it, nutrients which are available in the restoration site. They can utilize them to grow quickly, and because they grow quickly and tall, they can get above the grass and close the canopy and choke out all those weeds which would choke out the seedlings. So by using these pioneer or early successional stage species, we minimize the time which is spent in maintenance, which can be where most of the money is also spent. So if we can plant trees which grow quickly, close a canopy quickly in the minimum amount of time, then we need to spend less time weeding and maintaining that site. So a framework species method would be using species much like in Trinidad you would use a lot of the Kiskadee woods or the Vismias, which are early successional stage species. You could also use the Citarexilums or what are they called again? Citarexilum, I think they're called cutlet. That's a common name there. You can also use Cecropias, which will grow very quickly, balsa woods or bois flos, which would also grow quite quickly, and use these species to close the canopy so you no longer have to worry about the trees and so on. Okay? Now, the framework species method necessarily uses a relatively small diversity of species, so you don't really use that many species. And that means that what you're aiming for there is really to set the scene or close the canopy so that you create that understory canopy with high humidity, low light, which is no good for the weeds and the grasses and so on, and also reduces the risk of fire, but is very good for the later successional stage species to establish in. Quite often when you do a framework species planting, then you can just leave it afterwards, after canopy is closed, and wait for the later successional stage species to disperse in. Unfortunately, this means that the framework species method can only be used close to a natural seed source. So unless you want to go in after the canopy is closed and start planting other species, then the framework species method really can only be used close to a remnant patch of forest or close to another forest where seeds will be dispersed in naturally by the different plants and animals. So the framework species method is used to rapidly create a good microclimate for the regeneration of later successional stage species, and to reduce the amount of work, amount of money that needs to be spent in maintaining the restoration area after it has been planted. Framework species method is useful because these early successional stage species will reproduce fairly early. Once they've closed the canopy, they will quite often start producing fruit and flowers, and this will attract in birds and bats and other seed dispersers, so that the species diversity, as long as there is a seed source around, will build up fairly rapidly. You would need to use species which produce fruit fairly early. So the vismias would be very good because they produce fruit early, as well as the cecropias or guacanos. Figs or the ficus, the trees in the ficus family, are also very good to use. They can grow quite quickly, probably not as quickly as the full-on pioneer species, but they have the advantage of producing a fruit, particularly in the dry season, towards the end of the dry season, where there's not much other fruit. So they really do attract a lot of dispersers into the area, and also allow bird species and animal species which colonize the restoration area a resource which they can use during the lean times of the year. So ficus species generally are very good framework species to plant. Framework species utilize all those lovely resources, but they must be protected during the dry season. They are quite vulnerable to desiccation, so it's a good idea to use some sort of tree shelter to protect the young seedlings of, or during the first dry season of, a framework species planting. They need to be fairly tough generalists to cope with these fairly dry conditions and variable conditions on a restoration site. And generally most R-selected species are pretty much like that. Get it? Alright, so the next method is the maximum diversity method. In this method, pioneers or early successional stage species are ignored, and the primary stage species are planted directly. So the K-selected species are planted directly into the ground. So what that means is that you don't have to wait for these species to disperse into the restoration area. They are already there. But the problem with this particular method is that it requires greater care and maintenance, because these K-selected species don't have the capacity that the R-selected species have to utilize all the resources which are available in this open restoration area. So maintenance is much longer, and trees will take much longer to grow. It's therefore much better suited to smaller sites, of a couple of hectares, so that the maintenance costs can be lessened. It's also better suited to sites which are much more isolated from natural seed sources. If you have a site which you want to restore, but it's a long way from any sort of natural bushland where seeds may be dispersed in, you may be forced to use the maximum diversity method, because that is the only method which can restore your site, because the seed from the other species would take too long to disperse into your site. It just wouldn't happen, basically. So species are chosen for being the dominants in the original ecosystem rather than the pioneers. So the maximum diversity method, used in areas which are far away from a natural seed source, relatively small, and in areas where you can provide a lot of maintenance and care for the site. The maximum diversity method also requires that you do maximum cleaning up, as it were, of the site, so that it can be so the later successional stage species will not be eliminated by weeds and so on. So maximum diversity method really does need a lot of site preparation. Framework species method also needs site preparation as well, to clear away all those weeds and give those seedlings a head start. This is actually very critical. Some of the practices in Trinidad which I've seen involve alley cutting, where just a alley through the grass and through the secondary last row is cut, leaving grass and the other shrub and other weedy species quite close to the trees. Now this is fine, but it means that you must go and tend and weed around these species all the time, okay, practically every week, every couple of weeks, because if you leave it any longer than that, the grass will encroach on your alley and it will smother all the tree seedlings. Much better is to just clear the whole site of all the vegetation. Let the dead vegetation act as a mulch, but all living things are eliminated through a combination of mechanical cutting and then herbicide spraying, leaving the vegetation on the ground, as I said. Once that is done, there is no competition for nutrients. Nutrients will also come from the decaying vegetation. There is no competition for water, and of course no competition for light. And this allows the tree seedlings a good head start, a good establishment. So site preparation is critical. So good site preparation allows tree seedlings rapid growth, freed from weed competition, and leads to a very rapid closure of the canopy. So although site preparation may involve more expense up front, it in the long run repays itself 2 or 3-fold by minimizing the amount of care and maintenance which is needed after the planting. If your area has been compacted by, say, grazing cattle and stock, or by passage of tractors and so on, it may be compacted. Compacted soil will lead to waterlogging and poor root penetration into the soil. So ploughing and ripping of the soil may be needed to quite often disturb or destroy weed species, but also to promote good percolation of water and allow roots to grow easily into the soil. So spraying and mulching, mechanical removal of weeds should be carried out. If you are in a seasonal area, quite often the seedlings, particularly if they're in the maximum diversity method, may need some sort of irrigation during at least the first dry season to allow them to survive. So maximum diversity method plantings will quite often need irrigation. Removal of some of the reasons why the area was degraded, particularly grazing, may require you to put in fencing, and Fire is quite often a reason why degradation occurs, so some sort of fire breaks should be cleared around the restoration site, which will enable the people monitoring the plantings to successfully stop the fire before it gets in to the seedlings and kills them. That will just favor the weeds and the grasses, which would remain in the soil unaffected, and will not allow your restoration to succeed. After you've prepared the site well, I would imagine something like mechanical cutting of the weeds, initial spray, leave it for a couple of weeks and then spray once again all the germinating weeds which are coming up. After about a week, then you can get into the planting stage. Planting should be timed well at the beginning of the wet season to give seedlings as much of a chance to become established as possible. Remember, these seedlings can easily desiccate. They haven't got their roots down into the water table yet, so they need to be protected during that first dry season, or at least given enough time to develop a fairly large root system so that they can maximize their chances of being able to survive that first dry season. Those trees, the seedlings, should be at least 30 to 50 centimeters tall at planting. Any smaller, and they simply won't have enough photosynthetic area or root area to survive. Any larger, and you have the possibility that the seedlings are pot-bound. In other words, their roots have begun to form a dense ball, which takes much longer to grow out of, and therefore takes it seedling much longer to establish. Okay, so you don't want seedlings which are too large, but neither do you want them too small. So between about 30 to 50 centimeters tall is best. At planting time, all the trees should be watered with at least 10 liters of water for each tree. 10 liters, that's a lot of water. But it's important because it settles the soil around the seedling which has been planted. It joins up the soil pores, and most importantly, it saturates those soil pores so the seedling has access to water to help it get over this transplanting shock that it undergoes when it is planted out into the field. So watering those new seedlings is critical, and it is recommended that about 10 liters of water be used. That's about 5 giliters for each seedling. So if you have a planting of about 1,000 seedlings, that's 10,000 liters of water. That's a lot of water. Fairly big weight. Alright, seedlings should be closely spaced, about 1.5 to 1.8 meters between the seedlings. Generally, forestry division will only plant seedlings at about a 2 meter by 2 meter spacing. Now, the reason why restoration plantings tend to plant closer together, as you can imagine, is because it closes the canopy more quickly and therefore forces out the weeds more quickly. So seedlings should be planted relatively close together, closer together than forestry division would recommend. But remember, we're not growing these plants for timber production. Because they're quite closely spaced, growth of these seedlings may need to be monitored, and if when they reach 5 centimeters dBH or maybe even 3 centimeters dBH, thinning may be required to release the remaining species so they can grow up faster. But closing that canopy is the most critical thing, at least initially. If we don't close the canopy quickly, okay, you will be stuck with the task of weeding and getting rid of all those weeds for a much longer period. Mulch is also very useful. Mulch is dead organic matter which can be added around the base of each seedling, and that has two effects. First of all, it prevents weed seeds germinating and growing up because they're shaded. And secondly, it can maintain the moisture in the soil, so the moisture is less likely to come up through the mulch, okay, and evaporate away. Instead, it's kept in the soil where the plant can access it. So mulch is a good thing to use. Or along with mulch, you may also use tree shelters. Tree shelters are a strip of plastic which is wrapped around pegs which are placed around the seedlings to form a small enclosure. Now this small enclosure, if it's of clear plastic, doesn't reduce the light too much, but it can reduce the temperature through shading of the seedling, and it can increase the humidity around the seedling, which will decrease the chance that that seedling will dehydrate and die because of lack of water. So the thing which you've got to watch out for with tree shelters, however, is they do also increase the temperature around the seedling, and that can effectively cook the seedling or make the respiration rate of the seedling reach so high that it cannot support itself. So tree shelters need to be used with caution. They can have a lot of benefits, but they may cause problems if they're not monitored. We need to really test them in Trinidad's climate, and the next restoration planting that I do, I'm going to test them. Alright, maintenance. After you plant comes the differential species performance. So this is also known as maintenance. The maintenance of the seedlings which you have planted. So follow-up maintenance is quite often where a restoration attempt will fail. It's very showy and flashy, and you can take lots of nice pictures to show the clearing of the site and planting. It's always good to have a lot of people there for the planting and takes good pictures and so on, but after that comes the hard work. Weeding, removing of competitors is very important, and there will need to be at least some weeding. Spraying and mulching are also used in Australia. Spraying of herbicides. The herbicides would be low residual herbicides, maybe Roundup, which do not persist in the ecosystems, and they will kill back the weeds for at least a month or so. The restoration site will need to be monitored all the time, so a walkthrough should be done to see when a spraying for weeds is needed. Mulching is also very important, and as I mentioned earlier, in the early stages, tree shelters can also be very important. Planting may also involve fertilizer. A handful of slow-release fertilizer thrown in the hole which the seedling is being planted in is a very good start for that seedling. During the growing season, subsequent to planting, there may be the need to apply further slow-release fertilizer around the base of the seedling. This can only or should only be applied during the wet season. If it is applied during the dry season, there is a chance that that fertilizer will burn or poison the plant by creating a very salty condition around the roots, and so drawing the water out of the roots rather than the water being able to go into the roots. But fertilizer can be very important, particularly in restoration of quarries where subsurface soil has been brought to the surface and therefore has very little in the way of nitrogen. Okay, let's move on to our next regeneration method, and that's the natural regeneration method. The natural regeneration method utilizes the principle that you don't really need to do any sort of regeneration other than removing the factors which created the degradation of the site in the first place. and then allowing natural regeneration to follow its own course. So what natural regeneration requires is you going into the site, maybe fencing it off to protect it from grazing, then spraying and slashing the weeds, and then just leaving it. This obviously natural regeneration system should be monitored, and every time the weeds look like they're getting big, it should be sprayed again. But care should be taken with subsequent sprayings not to damage any of the regenerating seedlings. And weed control should try not to coincide with maximum seed production in a natural forest, which in Australia is October to March, and I think in Trinidad, actually it might be around the same time as well. One thing that you need to be very sure with the natural regeneration method is that you should not use this method a long way from a seed source. Okay, so the natural regeneration method relies on seeds dispersing in naturally from outside your restoration area. Because of this, if you don't have a seed source nearby, you're not going to get the colonization that you need. So care should be taken to only use this method in close proximity to a seed source, to a forest or so on. So this natural regeneration method is probably not going to be that useful in the middle of a established farmland, for example. And you would have to use the maximum diversity method in that particular case. Alright, in Australia they also have a particular restoration method called the riparian rehabilitation method. Now this is because watercourses have been particularly focused on for restoration in the Australian context. Mainly because where all this rainforest restoration has occurred, forests have been cleared right up to the watercourse banks. This means that these watercourse banks are foci for erosion. It also means that a lot of fertilizer and sediment goes into these streams. Once these streams join with the bigger rivers, these rivers can be very polluted with fertilizer and so on, and sediment, and those rivers will flow out directly onto the Great Barrier Reef. All this fertilizer and sediment is not good for the reef and blocks the sunlight going to the coral polyps, and which can kill off large areas. So rehabilitation and restoration, particularly on riverbanks, has been prioritized in the agricultural areas immediately adjacent to the waters of the Great Barrier Reef. So watercourses require particular attention as they are the foci for erosion and the foci for causing land-based effects on these coral reef, which are a major focus for tourism, international tourism. And if the Great Barrier Reef is lost, then that means there's a huge industry which is lost for tropical North Queensland. Weed vegetation should be removed, as has happened with the other restoration methods, but mulch should definitely be used. Mulch should be used to make sure that the amount of time that there is any sort of bare soil is minimized, so the amount of erosion again is minimized. Species should be planted according to their ecological zone, and because you're quite close to a watercourse, there can be quite a large amount of water in the soil, so species need to be able to be adapted to that. And several zones have been classified around watercourses: water edge, creek flat, stream bank, and levee bank. And there are particular species which specialize in each of these zones around the watercourse. So there you have restoration techniques. All of these things are covered in the the PDF Rainforest Restoration Manual, which I have provided a link for on My Learning. I strongly suggest that you take a read of that. You can skim through it and take a look at the framework species method, maximum diversity method, natural regeneration method, and riparian regeneration method, and the manual go into more detail than I've covered here in this lecture. Okay, thank you very much, and I will talk to you later. Bye-bye.